Thanks for joining us again for another Tech Talk. Today, we're going to talk salts and sodium and VR seeding. This is a pretty short one, so we won't take up too much of your time. I'm Trevor with Crop Care in Western Canada, so let's just dive right in. So why do we want to talk about salts and sodium? It's becoming more of an issue in Western Canada specifically. It's taking more away of our productive land, and you think about that. Often zero yield on a lot of these worst spots. So how much of your field do you need to boost yield in order to make up for what you lost on these zero yield spots? And as they're growing and growing and growing, if you are doing VR, maybe you are not putting as much fertilizer in those areas, or potentially nothing. So you're trying to manage your inputs that way. But these areas are not going away, and if you're not doing anything about them, they're going to continue to get worse. And you're paying, good value for your land, and spending a lot of money on taxes on these spots that are not yielding you anything. So we need to start taking this land back. So what is a saline soil? Well, it's high levels of soluble salts, usually caused by excessive water, and it prevents the plants from taking in water. So plants in those areas actually look drought stressed because the salt is so heavy there, and just the plants can't get access to the water. So we look at some salts and just showing you how much more accurate the Soil Optics is mapping. This is a grid sample, a 5-acre grid sample from the fall of 2014. We have the same legend as we have over here, and you can see the Soil Optics has really dialed in the salts. And unfortunately, this field has quite a few challenges with salts, but the Soil Optics has allowed us to define it better, so we can go in and start trying to manage those challenges. What is a sodic soil? Well, these are high levels of excessive sodium. It significantly degrades your soil structure. So these soils are harder to till. We get very poor seed germination and restricted plant growth because we're dealing with that excessive sodium. So again, looking at a grid sample from the fall of 2014 versus a Soil Optics from 2018, you can see that the Soil Optics has dialed in where the sodium challenges are better on this particular field. So we're going to go through just a quick example of the field, and you're thinking, well, why are you talking variable rate CKD in lime? Well, this is just going to tell a bit of a story. So if you happen to watch our Lime Tech Talk, this would be referencing that same field because it does tell an amazing story. So we averaged about 3,300 pounds of CKD across this particular field based off of the pH and the calcium levels. And just wanting to show that the pH started with a grid sample on the fall of 2011 at 6.1. This grower applied gypsum and stuff to the field because it was good for sodium, actually dropped his pH to a 5.6, and now with the CKD and lime application, we brought the pH back up to a 5.9. With the calcium, we started at 37%, it dropped to 32, and now we're back up to 48. So we're heading it in the right direction, finally. And a side effect of adding the gypsum but not attending to his calcium levels dropped the magnesium in the field down to 10%. Now we're slowly bringing that number back around to 13%. Why are these things important? Well, because if you're going to go attack sodium with gypsum, as you've heard maybe in a meeting, or maybe you're listening to me and jumping ahead and wanting to use some gypsum, it does work. It absolutely does work. However, it won't work unless we get our calcium levels correct, as we saw above there. And in these situations, we need a good quality map, and then we can decide the recipe that we need to move that field forward and change what we're looking at. And we might need to look at drainage in a lot of cases too. So do we start drainage first and then nutrient amendments second, or do we do the nutrient amendments first and look at the drainage second? But you got to be aware of what you're dealing with so you can do the proper planning. So looking at that field with the original grid sample on the sodium side of things, you can see that we've got what is that? Almost 50% of the field above 12% sodium. Now we're down to 10%. You can see those areas are really fine-tuned to small areas. So we've shifted a lot of that field down to where that field needs to be, so the sodium isn't causing us near as much grief as it used to. And we're still chasing it out, and some of it we may never truly cure, but we can manage it now. You look at that field, and this is before the anything variable rate happened, and the grower placed 75 pounds of SuperCal gypsum in his seed row with his canola, and you can look at that plant stand, how much that improved that plant stand by having a little bit of calcium there. And when we look at the economics on that, this gave us at the end of the year 7 bushels better for a $13 an acre cost to manage it. So there's times where we may not necessarily be able to fix a field because it's just too costly, but we can manage a field, and doing some small things like this might be the ticket in your situation as you're trying to understand what's going on in your fields. And it may not be the right approach. So it just depends. There is no standard recipe. The recipe is dictated by what we see on the soil maps that we get from Soil Optics. Well, can we change the salts? Usually we have to fix the drainage first. However, there are strategies that we can use to reduce the impact of the salts on that crop. Most companies will tell you to reduce your inputs and VR seed, but they're not really looking at the root of the issue. They're just telling you not to put inputs there. Well, that's an easy button fix. We want to know why are these problems there, and is there anything we can do about them? So here's that same field again, and we looked at that original grid sample. We're ranging to an average of 0.8 salts, but look at the high end at 3.3. Now with that Soil Optics, that same fall of 2019, we dropped that top end now to a 1 and basically cut our salts almost in half. Well, how did we do that? Well, the grower, with the literature that he had at the time and trying to understand things, site-specific put 3,000 pounds an acre on gypsum of the worst spots. He did a blanket spread of 500 pounds of gypsum, which you would think, hey, this is a good thing. But when you look at what the combination of these did and how it lowered his soil calcium, lowered his magnesium to a deficiency, and lowered his pH and sent it the wrong way. If we would have had a lime application in with this to bring the calcium around, then we wouldn't have seen those problems happen. Plus, he has about 30 gallons of humic acid over those number of years, because the humic acid helps complex the salts and the sodium, so it gives the plants a chance to get up and grow. And then the 3,300 pounds of CKD. So there was a good investment on that field, but this is land that used to grow 20, 30 bushel canola. Now he's disappointed if he gets under 50. We're into the 60, 70, 80 bushel wheat, where before, 40 bushels was a big crop. So yes, this is expensive, but that investment turned land around that couldn't grow anything. So that's huge in the end. Well, how do we deal with these issues? Well, it ultimately depends. We need a good map of what the issues are. Then we can start to build the recommendations for the issues in the different areas of the field. And it could be a combination of any of the following here. It could be drainage we need. It could be gypsum, lime, combination of. Humic acid could play a part of it. Reduced input, certainly. Looking at variable rate seeding. And sometimes we just have to walk away from these spots because there's nothing that we can do to fix them. And this is a hard thing to come to realize, but that's the reality in some instances, that we just got to walk away. So just going to briefly show a couple of different examples on variable rate seeding. So this is a canola field. You can see we're ranging from a low end of 4 pounds per acre up to 7.5, depending on the different background soil properties, with an average of 4.8. Here's another example of wheat with an average of 128, ranging from 103 up to 158. You can see that in most of that field's in that 119 to 124. The grower thought he'd be more in that 124 to 130, but when we calculated it all, a little bit lower for the majority part of the field, but we still got his average in that 128, so they were pretty happy about that. So when we're looking at VR seeding, what do we look at to determine the rates? Well, it can be any combination of the below. We can look at the salts and the sodium. How does the organic matter play into that? Low organic matter, certainly the wetness potential and how water moves in the field, and ultimately the texture. How much do we need to boost the rate on a low organic matter in a sandy area? Do we have salt, sodium in other areas of the field? Is it an area that's wet? Is it an area that's dry? How does that all play into managing the seed that we have? With that, that's just a brief overview of salts, sodium, and some variable rate seeding. If you have any questions, don't hesitate to reach out to myself or to Soil Optics, and we'd be more than happy to help you out.